So this is the first in a series of videos showing you how to analyze HR PToF data. The first thing we're going to do is press this button, define and prepare raw PToF spectra. The very first time that you do this, this will be a blank graph. So the first thing to do is select a to-do wave and select a single PToF data set. And then this graph will fill in. The x-axis is your PToF bins in PToF time space. This is seconds. So this represents one revolution of a chopper. And this is the size that corresponds to different measurements from the beginning of the chopper spin. Most people have calibrated their PToF signal on the range of about 100 to about 1,000 nanometers. So this is going to be the range I'm going to focus in for this data set. So the first thing I'm going to do is create a single PToF data set, and I'm going to press this DC region 1. When I do that, these two lines filled in, and this corresponds to my DC region 1 from my DC marker graph. And to kind of get a feel for that, I can press the DC markers graph, and I'm just going to do a run at random here. And let's do it for our favorite ion, 43. And notice when I analyze my unit mass resolution PToF data, I'm going to redo this real quick. I have about 120 runs in this experiment, so you kind of can get an idea as to how fast your computer is compared to mine. But when I analyzed my PToF data, I noticed that I didn't take enough data far out here on the right-hand side. And this region, which corresponds to my background, is lower than this region over here. These are 10, 100, and 1,000 nanometers. And we don't believe that we're actually seeing aerosols corresponding to this size. This is just slowly vaporizing things. But I noticed it never kind of got back down to where it should have in this background. So I selected a couple of options here. I'm using only region 1. That means this is the only region that I'm using for all the UMRs that are not in this list. This region corresponds to this region in this time space. And the other thing that I'm going to notice when I create my raw PToF spectra group is that my maximum M over Z I'm going to set to be about 120. This is going to be the highest HR peak that I'm going to fit for this data set. So go ahead and set this a little bit higher, but it's set to be close to the default of the list of HR peaks that were fit. And now I'm just going to press this button, and what it's going to do for every run in this to-do wave, it is creating a two-dimensional matrix. It's just a single PToF data set, averaging all my DAC bins from bin number 20 to bin number 28, which corresponds to 16 to about 47 nanometers, which is this region, which corresponds to this gray region right here.